Hello students, welcome back to my channel. Once again, this video I am going to explain Freundlich adsorption isotherm, which is under adsorption isotherms. Students, this is in the chapter adsorption or surface chemistry. Okay, so Freundlich adsorption isotherm. Are you all ready, students? Okay, whoever is watching for the first time, please subscribe the channel, and whoever already subscribed, don't forget to like the video and share the video, students. Okay, and without any delay, let's try to understand what this Freundlich adsorption isotherm is. First, let us know what is an adsorption isotherm. Adsorption isotherm, here I mentioned, students, it is the curve which explains the extent of adsorption. That means how much a substance is being adsorbed, that is the extent of adsorption with the pressure keeping the temperature constant. Such curves we call them as adsorption isotherms. Okay, so the curves which explain the extent of adsorption with the pressure at constant temperature. So three you have to remember, students: extent of adsorption, pressure and constant temperature. Okay, so the curves which explain the extent of adsorption with the pressure, okay, at constant temperature. Now, one of the adsorption isotherms is Freundlich adsorption isotherm. Freundlich, he proposed an empirical equation which was obtained by, that means Freundlich plotted a graph between extent of adsorption and pressure keeping the temperature constant, students. By doing so, he could propose an empirical equation. Here, extent of adsorption is denoted by x by m, and pressure, you all know, it's P. What is x, students? X is the amount or weight of the gas adsorbed by m grams of the adsorbent. Okay, so extent of adsorption is denoted as x by m. X is the amount of the gas adsorbed by m grams of the adsorbent. So this extent of, that means x by m, is plotted against pressure keeping the temperature constant. By doing so, he could propose an empirical equation. So below is the graph between x by m and P, students. Okay, you have to show the graphical representation. From the graph, what do we understand, students? Okay, pressure is taken on x-axis and x by m on y-axis. So at low pressures, at high pressures and at intermediate pressures, let us try to understand the graph which is plotted between x by m, that is extent of adsorption, and pressure, students. At low pressures, the graph is almost straight or nearly straight, and the graph satisfies the equation x by m proportional to p power 1. What is p power 1, students? P power 1 equals to p. That means x by m proportional to p, directly proportional to p. Okay, so as pressure increases, x by m also increases. This is what we understood at low pressures. Coming to high pressures. Okay, you have the graph now, students. Look at the graph. At high pressures, x by m is independent of pressure, and the graph satisfies the equation x by m proportional to p power 0. Anything to the power 0 is 1, students. Okay, so x by m proportional to p power 0 means here x by m is not depending on pressure. It is independent of pressure, and hence we can write the equation like this: x by m proportional to p power 0. Okay, now coming to intermediate pressures, x by m is depending on pressure. How much it is depending? It's depending on pressure to the powers between 0 to 1. How can we say that? At high pressures, it is p power 0, students. At low pressures, it is p power 1. At intermediate pressures, it would be obviously between p power 0 to p power 1. Okay, so that's what here I mentioned. X by m is depending on pressure to the powers between 0 to 1. What will be there between 0 and 1, students? Obviously, it would be a fraction. So that fraction we are mentioning as 1 by n, and the graph at intermediate pressures satisfies the equation x by m proportional to p power 1 by n, 1 by 2 or 1 by 3 or 1 by 4 or 1 by 5, like that. Okay, so pressure to the powers 0 to 1. Okay, that we are writing it as x by m proportional to p power 1 by n, students. Put it in a box, and this equation we call it as Freundlich adsorption isotherm equation, students. So simple, over. Okay, so graph between x by m and pressure, and that graph you will be explaining at low pressures, high pressures, intermediate pressures, and later we need to do some experimental verification. Okay, so below the box you write down, this is called as Freundlich adsorption isotherm equation, students. Now put the side heading, experimental verification of Freundlich adsorption isotherm. Okay, now what is Freundlich adsorption isotherm equation, students? X by m proportional to p power 1 by n. Let us remove the proportionality. You all know that there comes a constant. So here the constant taken is x by m equals to k into p power 1 by n. Okay, so taking logarithm on both the sides. Left side there is x by m, right side there is k into p power 1 by n. So taking logarithm, log x by m equals to log into k into p to the power 1 by n. Here we will be opening the brackets, log k plus log p to the power 1 by n. Log x by m will be equal to log k plus whatever is there in the power that comes forward, students, 1 by n into log p. Okay, now this equation resembles straight line equation. What is straight line equation? Y equals to mx plus c. So here y is equal to log x by m, x is equal to log p, m is equal to 1 by n. Okay, so m is 1 by n, students, x is log p. Y is equal to mx plus c. C is equal to log k. Okay, so now suppose if you plot a graph between log x by m. Okay, that means log x by m should be taken on y-axis and log p should be taken on x-axis. Then we should get a straight line. Obviously, we will get a straight line with the slope 1 by n and intercept log k. So here is the graph, students. You have to show the graphical representation. Okay, y-axis log x by m, x-axis log p, and you will get a straight line like this with the slope 1 by n and intercept log k. So this is how Freundlich adsorption isotherm equation is verified, students. All clear? Yes. Easy to understand? Very good, students. Okay. So if you have time, write down the points or fatafat take screenshots and prepare for your exam, students. Meet you in the next video with a new topic. Take care. Bye-bye.